Hey everyone, Dan here with Hardly Brief Tutorials. In this video, we're going to take another look at the Unity input system and some more advanced controls and interactions that system allows us to use in our projects. If you haven't watched my first or now second video on the Unity input system, I would highly recommend checking them out, and I'll go ahead and link them now. They'll also be linked in the description below. The first video goes over the basics of setting up the system and getting some more controls to work, downloading it from the package manager. The second video covers some of the more advanced features that we're actually going to expand upon in this video. So in this video, we're going to cover more interaction types and more of the processors that you can actually apply to those interaction types, and we're going to connect them all to our rigid body movement controller to get our character moving around on screen. We're going to take a look at the multi-tap interaction and how we can use it to make our character dash. And lastly, we're going to use some of the input processors such as scale and normalize and see how those can actually change our controls. If you haven't already, go ahead and hit the like and subscribe button, and make sure to click the notification icon to get reminded when I do release a new video. It really does help the channel out a lot. And if you have any questions or comments, leave them down below and I'll be sure to get back to you and respond. One more thing, I set up a new Discord server for the community. I created two major sections on the server. One is for Hardly Brief Tutorials, where you can ask me questions, you can ask other people questions, get some help on whatever you're working on. You can chat with other game developers, and you can even suggest tutorial ideas. So if there's something that you want me to work on, something you want me to show you how to do, add it there and we can start working on it. Also, I added a channel where I'm going to be posting the scripts from the videos that I create on the channel. So if you become a member of the Discord, you'll be able to download those scripts. The other major section is a personal devlog of mine for a tennis game I've been working on. So be sure to check that out, follow along. I do post frequent updates on that, and I take suggestions as well. I have also created a Trello board for everyone to follow along to check out and see when videos are going to be uploaded to YouTube. You can see what I'm working on. You can see what's going to be released next. And then all the suggestions I get from the Discord or from Twitter or from the YouTube comments, I'm going to put in the backlog on that Trello board. And then maybe we could do some voting or something to show you, to figure out what exactly everyone wants me to work on and show you how to do. So if that all sounds interesting, again, please join us on the Discord. I'll put the link in the description below. But let's go ahead and get started. In this part, we are going to explore how we can get our character to move around. So you see I have the controller on screen now. I'm moving my left analog stick. I can also use the W, A, and D keys to move around. But I'm using my left analog stick to move my character. If I hit the Y button, we'll jump. Hit the space bar, we'll jump. And then if I double tap X, I can dash. Right? And I can do the same thing on the keyboard with left shift. Right? And lastly, we're going to look at using the left trigger on the controller. And if you look down the console now, we're going to look at how we can scale this value from 0 to 1 to 0 to 100 by using a processor. So when I'm fully in, it goes to 1. When I fully let go, it goes to 0. And then it shows every number in between. What if we don't want to go to 0 to 1? We want to go to 0 to 100, 0 to 1,000. We can manipulate this value to do that. And that's what we're going to look at in this video. So the first one we're going to take a look at is the move vector. I'm going to go into my input actions asset. Again, I have one action map called player controls, and the first action I have here is move, and that's the one we're going to look at now. So in the action type, I have it set to value. I've changed it from button to value, and then control type, I've set it to vector 2. You can also, with a analog stick on a controller, you can also use a stick or an axis, but I'm using the vector 2. I find it works better for what I have been working on for the rigid body movement controller and everything, but you can definitely play around with them. Here I have a left stick. I have two bindings, right, for my move action. The first one's a left stick, and what I've done is I've actually added a processor on it called normalize. So one thing that happens with the analog sticks is that the values go from -1, 0, and 1 in every number in between, right? And with the keyboard, you have on or off, so you get either -1, 0, or 1. You don't get those values in between. So when we normalize the vector, we're actually going to normalize the analog stick to only be -1, 0, or 1 in those XY coordinates, and that way it will map directly like the keyboard does. So there's no differences between using the controller or the keyboard, and that's important. So that's why I added that processor there, and that's something that's often overlooked when using this input system. So the other thing I have here is W, A, and D, which is a composite of 4 bindings, right? And what this allows me to do is say that these 4 bindings, up, down, left, right, which I've tied to W, A, S, and D, are what generate my vector. So up and down is a positive one and a negative one. Left and right is a positive one and a negative one. And the way you do this is very simple. When you set up an action to be a vector 2, some options become available when you add a binding, and you can actually add an up, down, left, right composite binding. And I'll go ahead and add one now. And you can set those values up. So let's say we want to use the arrow keys. I'm going to go ahead and call this keyboard. I'm going to turn off autosave right now so it doesn't kind of lag as I do this. But basically we can click the up button. I can go to path, listen. I can hit up on my keyboard, select it, go to down, do the same, listen, down. And we can actually tie our arrow keys to our movement as well without doing much work at all. So now I have that set up. I'm going to turn autosave back on just so it regenerates everything. I'm going to go back into Unity, press play, and use the keyboard, the arrow keys to move around. And then we're going to jump in and look at the code. So now I've set up the arrow keys. I'm pressing them. I know you can't see me doing it, but I am pressing the arrow keys on my keyboard and can still jump and do all that. So now that we have it set up in our asset, let's go ahead into the code and look at actually how I coded it and how to set it up with your controller. I'm in my player controls class, and this is the same class that was in the last video that I discussed. And again, these are all available to download in the Discord. If you join the Discord, you can download these scripts. So if you kind of get lost as I explain it, they're there for you to download. One thing to note about this video and getting our player to move properly, you are going to need to reference my rigid body movement tutorials, which I'll go ahead and link in the video now. But basically what I do to get our character to move is I implement this eye movement controls interface that requires me to have this public property called move direction, which is a vector 2, and we set up our controls in our setup method to set that variable move direction equal to whatever the value is coming from our controller or keyboard. So and I'll run through this interface in just a moment, but let's talk through the player controls class. So again, I have player controls class inherits model behavior. I do have a public property move direction that's a vector 2 that just returns the private vector 2 move direction value. That's what these two lines of code are for. I have the Unity awake method here. On the awake method, I instantiate the game controls asset, or the class, excuse me. And then we call the setup method. The setup method goes through and sets up all the controls and the events and stuff that fire based on whatever we're doing on our keyboard or controller, whatever your input interface may be. For here, we're going to say game controls. We're going to get our action map, which is the player controls action map. We're going to look for the move action. And when it's performed, meaning I'm pressing one of the keys or moving the analog stick, we're going to read the value from the controller or keyboard as a vector 2, so XY coordinate, and we're going to cache it into the move direction variable. That again, the move direction public property exposes that, and we can actually see what that value is. But again, when we're performing the action, we're pressing a key, moving the stick, we're going to be constantly updating move direction with this read value property here. And then when it's canceled, so when I let go of the keyboard or when I let go of the controller, the stick, we're just going to set this move direction vector to 0. So 0, 0, vector 2.0 just sets it to a 0, 0 vector. And that's what this is how you set up the move direction. It's pretty simple, but the way you tie it into the movement controller is a little bit more complex. So let's go into that. Again, this script is available to download if you join the Discord. But basically, I have an interface called eye movement controls where I require whatever implements this interface to have a public property called move direction, and it's a type of vector 2, and I reference that vector in my move method. So I have a move method that's in my movement controller, which is a model behavior that's attached to my character. It requires a rigid body, but basically I have a move method where I capture the move direction. So I create a new vector 3 because we're in 3D space. So I create a new vector 3 called move direction. And I just say movement controls dot move direction. That's the public property from our player controls class. And I'm setting the dot x value, so our x coordinate as our x. I zero out the y because in 3D space that's the vertical movement. So if we're jumping, you would be in the y axis. And then I set the z value equal to the move direction dot y, again because we're in 3D space. If you're in 2D space, you would just use the move direction vector 2 and not have to do this. But that's how I apply the movement direction. Then I multiply it by speed factor and a move force, and this is done every frame for rigid body. So hopefully that makes sense. Now we're going to take a look at how we can actually get our jump to work, and we're going to go back into Unity to look at that. Okay, so now we're going to take a look at jumping, and I'm going to press play. And this one's really simple. I have the Y button on the controller hooked up to jumping. So if I press Y, we jump. And then if I hit spacebar, our player jumps. This is probably the simplest of buttons to get working, or inputs to get working. So let's go ahead into our input actions asset and take a look how I did it. So again, I have the player action map, player controls, and then I have a jump action. I have two bindings on it, a spacebar and a button north, which happens to be the Y button on the Xbox controller. And then it's just an action type called button. So let's go into the player controls script and we can take a look at how that's all coded. Let me turn off the controller before we do that. So here I am in the player controls class. Again, it's the mono behavior component that's attached to our player. I have an event here called jump. And what we're going to do is we're going to call this event if someone's listening for it. So we have a listener for it. We're going to invoke the event as soon as the Y button or spacebar is pressed. And I do that in the setup method that's called in the awake method. So in setup, I'm saying game controls dot player controls. That's our action map. We're calling the jump action, and we're looking for the jump actions performed event. So when I press the spacebar or when I press Y, as soon as I press it, this event will be called. And what we're going to do is we're going to look for any listeners that are attached to that jump event. If there are a listener, if someone's looking for this event, then we're going to invoke it. We're going to start it. So that's really as simple as how you get jump set up. And I have this again tied into my movement controller. It's a requirement of the iMovement controls interface that you implement the jump event. And I have a method here called jump that basically just applies a jump force to our character. And that's called at the top. So basically here, in the moving controls.jump, I'm subscribing to this jump event so that now it does have a listener. And so when I press the Y button or space bar, it's going to go ahead and call this jump method where it applies a force, an upward force, in this case, a jump force to our rigid body as an impulse force. So that's how to set up the jump. Now we're going to take a look at how we can set up the dash, which is a multi-tap. The next interaction we're going to take a look at is the dash interaction. And this is a multi-tap interaction. And there's one thing to note about it, which I'll go over when we jump into the code. But let's go ahead and press play, and I'll show you how it works. So as long as I'm moving my character around and I double tap the X button or left shift on the keyboard, our character is going to dash in whatever direction that we're moving. And it works pretty well. But there's one little bug about it, which we'll take a look at when we go into our action map now. So let's open that up. I'm going to double click my game controls asset. And here I have two types of dashes in the actions. I have a controller dash and a dash. Now the reason is they do the same exact thing, but the reason in Unity right now there's a bug where basically if you have two bindings on a multi-tap interaction, the second binding the bindings won't work. So you actually have to create two different actions that point to the same event. At least that's the way I solved it to get this to work. It is a known bug in Unity. They are working on it. It's been reported. But if you want multi-tap to work in your project right now, the easiest thing you can do is create two separate actions, and then in code, which I'll show you, we will set up so they call the same event. So anyways, I have a controller dash that connects the X button, and then I have a dash that is tied to my left shift, and they're the same exact multi-tap event. You can choose how many taps you want. You can choose the window, so like how long you have to do the multi-tap. You can determine the press point, which is like how far you actuate the button before it begins these timers. And then the tap spacing. So this is a timer. The tap spacing is the time between each tap. So if you have 5 taps and you have a half second between each tap, this spacing value will determine if you've actually reached that or not. And then again, you have the same events that get fired. So started, performed, and canceled. I think there's activate and deactivate as well. But let's go into the code and take a look at controller dash and dash. And I'm just going to load up Visual Code. Again, I'm in the player controls class. I have one event here called dash, right? And so what I do is I actually call this dash event, and excuse me, I jumped around a bit, but I call this the dash event at the same for dash and controller dash. Because of the same thing, I just had to create two different actions because of a bug in Unity right now. But basically what I do game controls dot player controls. That's our action map. I look at for the dash and the controller dash, and I look for the on perform. So basically, if this multi-tap was successful, I tap twice within that window of time and within the spacing, then we can go ahead and invoke the dash event. And then whatever subscribes to that, in my case, my movement controller subscribes to this dash event, we can move our player. So again, because of the Unity bug, this is the way you should split up multi-tap interactions if you're using both a keyboard and a controller. But let's go look at the dash event and see what it does. So in my controller here, and it's actually in my class. I expanded the movement controller to add dash to it. So here I'm in a player movement controller. This inherits the movement controller, which is all this. So the player movement controller has all this functionality plus a little bit extra, and this is where I do the dash. So again, this is in the rigid body movement tutorial if you want to check that out. But basically, what this does is that it's looking for player controls. It's going to look for the dash event, so controls.dash, and it's going to subscribe to it. And it's when the dash event goes off, the on dash method down here is going to be called, where it applies a horizontal force, a dash force, to the movement direction. So whatever our movement direction is, we're going to apply a force to it, and it's going to be impulse. So this is just like a jump, but instead of going up, we're going to be moving to the left or right, or whatever direction we're moving into. And that's how you set up the multi-tap. It's pretty simple. Again, the only bug being the issue with having to have two actions. And it's fun to play around these timings. I left them on default because it felt pretty good to me. But if you want a more time intense tap, where like you want to shorten the window, you can go ahead and lower the max tap duration to 0.1, 0.05 if you really need it to be fast. It's really dependent on whatever you're developing. But now we're going to take a look at the left trigger scaled, and that will be it for this video. So the last thing that we're going to look at in this video is the left trigger scaled example, and this is just to talk about some processors that are available to us that we can manipulate the inputs the values that are coming from our controller or keyboard. So in this case, I'm using the left trigger, so I created an action called left trigger scaled. You can name it whatever you want. I've added one binding to it, which happens to be the left trigger on my gamepad, which is the Xbox controller, and I'll turn that on so you can see it. So here's my left trigger flashing on the screen. And again, we're going to look at the processor. So there's a bunch in here. If I click this plus icon, you can see we have an axis dead zone, a clamp. The clamp clamps a value between certain thresholds. So if you want it to go from 0 to 0.5, you can clamp it there. Invert will just revert it from 0 to 1 to 0 to -1. Normalize we use as the example in the move where we lock it down so that it goes from -1, 0 to 1. And then lastly is the scale, which is we're going to use in this video, where we can scale the factor of the trigger. So right now, scale 1 means nothing has changed. Let's go into Unity, and I'm going to show you the values before we do manipulate them. So I'm going to press play. Again, I have the controller on the screen here, and as I slowly press down on the trigger, you can see the values are 0. They go 0.17, 0.25, 0.3, all the way to 1. When I'm fully holding in the button, it goes to 1, right? And when I let go, it goes back to 0. But what if we don't want 0 to 1, we want 0 to 100? Well, the scale processor allows us to do that very simply and quickly. So here I have the scale factor, and you know what? We're going to remove this and we're going to put it on the action itself. We don't want it just on the trigger. We want it on the full action. So you can add processors just on the individual bindings like we did with left stick where we normalized it, or you can add it to the overall input, which we're going to do here. So I'm going to go left trigger selected, the action itself is selected. I'm going to go to processors, I'm going to add scale, and I'm going to change this to 100. And once it saves, we'll exit out of our action map here, or action asset, excuse me. I'm going to press play again. We'll open up the console, and the numbers are going to change from 0 to 1 as I hold down the trigger to 0 to 100. And you see now I'm 15, 16, 25, 40, all the way up to 100 when I hold it in. And what this is doing is just literally multiplying that value by 100, right? That's what scale does. It's multiplying whatever factor you put in there by 0 to 1. So it takes 0 to 1, multiplies it by that factor, and gives you this value. Now, the way to output this value, the way I do that, I'll show you. In Visual Code, I'm in the player controls class, right? The one that we've been writing all this code in is mono behavior. It's attached to my player. And it's very simple. What I do is I look for the game controls. I look for the player controls action map. I call the left trigger scaled action, and I'm looking for the performed action. So every time I'm holding down this trigger, let me turn off the controller. Sorry about that. Every time I'm like squeezing, I'm manipulating the trigger. We're going to debug a statement out that says trigger value, and we're going to read the value, which is float. Now, remember, this is a float value. So if you put it int here, or so if you put it int here, it's actually going to throw a bunch of errors, and you don't want to do that. So it's a float. You can cast it as an int though, which I'll do. So if you don't need the 0.00 whatever, if you don't need the decimal value, you can cast this as a float, right? Putting int in parentheses in front of it. And we'll go back into Unity. I'll press play, and you'll see instead of 98.82 whatever, it's just going to say 98.53, whatever the value is. Let's press play. Hold the trigger down, and you see 3, 4, 12, 13. It's a little easier to read, and this might be better for your game logic, so you can cast it that way. It's just a simple way to do that. But that's a scale processor. Again, there's a whole bunch of different processors you can use. Test them all out. See what you think. Hopefully you guys liked the video. Let me know what you think. Leave down in the comments below. If you have any questions, you want me to cover something else on the input system, go ahead and leave them down in the comments, or join the Discord and request it there. Otherwise, I hope you guys have a good day, and we'll talk next time.